So in this video, I'm just going to make things a little bit trickier. I'm going to stick with my initial situation of the block of mass M as an angle of theta. What I'm going to do this time is I'm going to say that there is a rope, obviously with a tension in it, that is pulling the object up and it's accelerating up the slope. So whenever we have a change in force, we have an acceleration. What I want to do now is set up the situation in a generic form so you can see how it would work in real life. So if you recall, our mg acts vertically downwards, and our components that we need perpendicular and parallel to the slope are mg cos theta and mg sin theta. I'm also going to say that there is frictional force, and we have a coefficient of friction which is equal to mu. So immediately we'd have to put our reaction force in. So our reaction is equal to mg cos theta, equal and opposite. And we have two things now acting down the slope. We have our mg sin theta. And if you recall, our frictional force is equal to mu r. So mu times whatever our reaction is, which is mu mg cos theta, acting down the slope. Because we know that the object is moving up, and if you recall from video 1, frictional force acts in the opposite direction to motion. So what we've got here is we've got a number of forces acting in different directions, and we have an acceleration. So when we have a change in force on a mass, we have an acceleration. So the only thing we can really apply here is F equals ma. And if you recall, we always apply in the direction of motion, which in this case is up the slope. So if we look at this situation, we have T acting up the slope, minus mg sin theta, minus mu mg cos theta. So remember, the mg sin theta is the weight trying to pull the object down the slope. The mu mg cos theta is the frictional force holding the object back. And that must equal mass times acceleration of the object. Now, in most exam questions, what we've got here, we've got a number of unknowns, and they'll remove one. Usually, they'll ask you to find the acceleration, so you'll know mu, m, t, and theta. Or potentially sometimes they ask for the tension to create a specific acceleration. So again, they just rejig the unknowns that you have. But it is ultimately very important to know two things. One, is it moving up or down the slope? Because that will determine your frictional force direction. And two, it is ultimately important to remember that mg sin theta always acts down the slope. I always liken this example to pulling a sledge up a slope. You've got the weight of the person in the sledge trying to pull you back. You've also